Well, good morning, and thank you so much for joining me in my shop here. Today is the 16th of January. Yes, another cold day and snow out there. The snow's not going to go away now until probably late February or so. I imagine it'll be below freezing till then. So, interesting lesson learned from this radio. Nothing to do with radios in particular, but just a lesson in how far down the rabbit hole you can go all the time collecting evidence that it's not a rabbit hole and you're going in the right direction. And what I'm talking about is my thinking right from the start with this radio was the inverter was probably the source of the problem. I was surprised to find an electronic inverter in there, but I eventually discovered it was full of rattling nonsense. So wow, that's pretty obviously a shot device. And slowly in pursuing that and looking for absolute convincing evidence of its failure, I eventually learned that in fact some of the things I was attributing to trouble with the vibrator is really coming from my power supply over here, and its automatic self-limiting feature, which I failed to fully recognize, I guess is the right word. And just interesting how all the way along I'm getting, yeah, it's the vibrator, yeah, it's the vibrator, yeah, it's the vibrator, yeah, it's the vibrator, but none of them are 100% it's the vibrator. And then the last thing, no, it's not the vibrator at all. Yeah. So what did it do? So when I got the radio operating with its vibrator internal power supply, when I managed to do that, I just heard this terrible buzzing coming out of the speaker. You could hear the radio operating in the background, but this buzzing sound, which I've got to bet is this filter capacitor here. This doesn't even look like an appropriate capacitor for having in a radio like this, but we are going to find out. So first step is let's take a look at the schematic and see what size these capacitors are supposed to be. So we're talking about these two down here. They are shown as looks like 20. That'd be 20.0 and 20. I got to be 20.0 over here also. So two 20s, not terribly big capacitors, separated by this resistor, 1800 ohm resistor we saw in the radio, in good shape, looked to be in good shape. The voltage these are going to be subjected to, it's going to be a little under 300. So these capacitors should be rated 300 or 400 volts to sit in this radio. And you know, I'm not that familiar with how all this works, but I imagine this is pretty spiky stuff coming through here. And so there could be some pretty high voltage spikes. I think there's some suppression that goes on right here with this capacitor to try to de-spike it, I think, and I'm not really 100% sure. But in any case, it's pretty rough what's coming out of here compared to your ordinary plug-it-in-the-wall radio. And that roughness probably beats up these capacitors pretty good. The original one is still in there but disconnected, and in its place is a classic 5-tube radio type capacitor. Okay, so let's go take a look at the capacitor now. My predecessor tried to tape this capacitor in here, and that's not going to work out. For some reason I'm taking the tape off, actually for no reason. I'm going to cut this out. I'm going to leave the wires, as they can prove to be useful. What do we got here? Well, it's a 450 volt capacitor. So I was quite worried this was a low voltage capacitor, but it certainly isn't. And it's a 2020. It's exactly what the schematic was calling for. So, right kind of capacitor. Is it still good? He says, look at his hand. Let's just give it a shot here. So if this capacitor has deteriorated and it's become leaky, and these are leaky from the start, testing them becomes a little bit difficult, in that you're going to get a result, but the result is potentially misleading. Let's see what we get out of this. "32 microfarads was supposed to be 20. What's coming back is 32, much larger, almost double. Well, 50% larger. Let's try the other one. So I believe that indicates the capacitor is very leaky. But this electrolytic, don't know about this tester on electrolytic. This one, 31. Also much higher than 20. Well, the best thing I can do is put in a new one, and new ones, and we'll see if the radio's troubles are abated. Okay. So I have this capacitor. The rating is only 300 volts. That's just a little above the rated voltage of the power supply here. This is a NOS, new old stock. So it's old. It's just never been used. And it's supposed to be 20. 33% loss. Yeah, that doesn't sound good to me. I don't think we're going to put this in there. So my options are a little limited. I do not have a 450 volt 20 capacitor, 20 or 30. I have to go up to 50. Really? 50 microfarads, and it's a direct to the capacitor from the transformer. There's no resistor in series with it. The first, so you would call that a I think you would call that a excuse me, a capacitive input filter, or a filter with a capacitive input. So we put too big of a capacitor there. The inrush charge current can be too much. Is that really a concern here? And I don't know. How do you judge these things exactly? So I'm going to hunt around a little more, see if I can find a suitable replacement. Okay, got a couple new capacitors installed here. I'm a little concerned about speaker going in and knocking into these. So we're going to stick the speaker in and examine the clearances around it. Let's see what's happening. So I can see it down there. I don't think you can see it. The speaker magnet is making this tricky. It's really grabbing. There's definitely a very close spot down there. Very close. Let's see if I can move it here. Move the capacitors. Yeah, they can go quite a ways. Towards the outside. What am I doing? Ooh. Yeah, so the ground wire here is up pretty high. The high voltage ones are down low. Let's push this whole schmozzle down. Okay. And when we put it back together, we'll have to take a close look at that and make sure it's not in trouble. I think we got to operate the radio here. But the time is 9:45. I have to attend to something else for a little while. Okay. Okay, I think we're ready now. It may be difficult to start this radio up. As I discovered with my particular power supply, I'm going to flip it on now. The radio itself is turned off. Okay. There's our 6 volts. I'm going to turn the radio on and hopefully this won't just disappear. You know, in this case, because there isn't a tube rectifier, the rectification process is not really a rectifier at all. The vibrator thing is going to start right away. High voltage is going to be produced right away. So it's going to try to charge this capacitor up right away. It's a larger capacitor than what was in there. That in itself may cause difficulties with the power supply. Give it a go. What are you going to do, man? Here we go. Oh yeah, also this voltmeter is hooked up across the capacitors. You can see a yellow lead here. It's on the 300 volt scale, so I'm expecting it to come up into this area here, the 250 volt area. Good luck. Okay, let's just try it again. One more time. Okay, how to deal with this? Set the output voltage higher on the power supply or lower to see if that helps. Don't know if I can go lower. Guess I can go lower. I don't think that's going to help though. Let's try it. Okay, then we're going to go higher. Just below 7 volts. Last time what I did was I preheated the tubes by having the vibrator out. I managed to heat the tubes, put the vibrator back in, turn on the radio, and with the tubes hot it didn't draw as much current. Wow, I don't want to do that. How do you deal with this? Pull a couple tubes out. That seems like also kind of an awkward way to deal with it. I don't have any other powerful 6 volt supply. There's just no way. I have a car battery, but that's 12 volts. Don't want to fool with that. It's just a situation I would just never have expected to be in. Turn the voltage way up, I think that would be a foolish move. To go any higher than that. Let's just a volt, but it's a volt in 6, so it's a high, it's a significant portion. Just a good question. What do you do now? What do I do? Every time I turn it on, there's probably a shot of current, but not nearly enough to warm up the tubes and drop their heater resistance. Pull out the 2 output tubes. Turn the set on. If it succeeds, let it warm up. Turn off the power, put in the 2 output tubes. They draw the most current. The heaters probably draw the most current. That's about the easiest approach here I can take. So we're going to pull them out. There's one of them. Delco. It's even got the car manufacturer's name on it. Where it says 6. These 6V6s. There it is. 6V6. Okay. Take out the other one. Now, operating the set with these tubes out, don't think there's any risk at all. And this looks also Delco. So these are the, I believe these are the originals. 6V6. Okay, radio. Can you start under these circumstances? I'm going to knock the voltage back down a little bit here. Is it enough? Yes, it is enough. Look at the voltage. Voltage here is 300. Ooh. The capacitors I put in are rated at 400, not much higher. Okay, we're not going to hear anything out of the speaker because, but I sure hear a sound coming out of here. What would I be hearing? I mean, there's the fan blowing over there in the power supply. I can hear like a buzzing sound right in this area. Well, it's probably just a transformer complaining a little bit. I don't think it could be anything else, really. Okay, so now we're going to, there's no doubt this, where did I get this from? Nope, no doubt. There's no doubt. Okay, given that fact, we're going to shut it off, stick these tubes in, and try to start it up quickly. I don't want the tubes to cool out. I got 2 of them to do. Okay, first down, off, and in you go. Don't cool off. This is taking too long. One in. we're still good. And the other one. Okay, both in. Got it. Okay, this time we should hear it. The voltage is way down from where it was. Without those tubes.
Personality stuff that I think has bonded him into being, one of the most famous offensive linemen ever. Like, beyond just the podcast and beyond his brother, like going back to the Philadelphia celebration, right, where he wears the
right on.
Chester suit. Like, there does seem to be something about this guy that resonates deeply with people, and I think it does go to some.
We're pulling, looks like about 6 amps.
Absolutely right. And look, this isn't a guy that came. Like, I respect him and how he earned these status because it wasn't coming as a first round top 15 center. He was a 6th-round draft pick, and so he earned it every step of the way.
I think my antenna is switched off.
These tougher cities, they appreciate, a blue collar.
So I'm just going to go check that.
Not glorious position.
Okay, I'll leave. It only takes me a few seconds to run through my house, throw a switch. So I'll leave this running, and you can hear the difference when we get there. Let me just tune it.
He shows off that, and he showed it off after they won the Super Bowl. He didn't show it off, maybe as a rookie trying to get attention.
Okay, just
I think that's right.
7.5 seconds.
Again, thanks for the time today. Again, if people want to listen to more, Eric, listen to the Standard on Buffalo podcast. Again, you're better than all right, okay? You made a Pro Bowl, so relax on that. Thanks for making time, Shane. Thanks for making time.
Yeah, my pleasure. Anyhow.
See you, man. Eric Wood. As soon as you actually know someone's good as I can, okay. Pretty good.
Okay. I'm sure you didn't hear it change because, in fact, the switch is on.
Just Saturday this week.
We're on the antenna here. The outdoor antenna. Very good. Okay, what else would I need to do to this radio? It's had its capacitors done. It all seems good. Got a really good B+ voltage here. I don't know if I should do anything more to it than that. Maybe that's just enough right there. I'm going to stop for a bit and have a ponder about that. I only pondered for about a minute. I think what we'll do is we'll check the IF tuning. We'll see how that is. That's a fairly straightforward thing to do. I have a signal generator here, which I'm going to hook up to the antenna. To the antenna of the radio this way. So we're feeding in this signal now, and we can make some kind of judgment about the sensitivity of the radio. I'm just checking a few things here. So the radio we know is tuned to around 680 right now. Let me turn the volume up again. You don't hear a thing. Oh, we don't hear a thing because there's no antenna on it as such. Okay. So we want to go to somewhere around 680. So, I don't normally do car radios, but if this were not a car radio, I'd be saying, oh, it's not very sensitive. Let me calibrate this before I make that statement completely. Yeah, I got a calibration problem there. Yeah, I'll take that back. So the radio sensitivity is in the ballpark of a radio like this. Seems a little off. You should be able to hear the tone there, but we don't. Okay. So I'm now going to pass this, I'm going to tune the signal generator to the IF frequency, and as I pass through the IF frequency we should hear the same thing we're hearing now, more or less. And the IF frequency is 260, way down there. Okay, let me calibrate. Way off. Okay. There we go, 260. So I didn't hear a thing. Give it more power. There it is. So the IF appears to be tuned to 268. That would throw the dial off. 268. 68 instead of 60, so it's 8. Well, I don't think it would throw it off too much. So tuning the IF involves turning, looking at the adjustments here and how accessible they are. So the two IF cans are way up in here, and they're both totally accessible. Okay, let's give it a tune up. Okay, so the objective here is to get maximum output out of the speaker when this is set to 260. That's the idea. If we go to 260, okay, we still just barely hear it. Let me just turn this up. Okay, make that louder. That's all we gotta do. Make that louder. Make that louder. Okay, now I'm just doing this by ear, which isn't the best way. Quieter. Louder. So right in that range. Yeah, it's usually better. Here, this one here. There's 4 of these I have to do. A lot louder. Yeah, a lot louder. Good. Let's try this one again. Here we go. Right in there. Okay, next transformer. Okay, make it louder. Right in there. Top. Make it louder. It's really not very distinct here. That's the spot. Okay, so we've tuned the IF up a little better. Put the radio back on the antenna and hear what kind of difference we got out of that. If we can even detect the difference. Pointer's jumping. Why is that?
Come out of there with the only option of going back to do postgraduate work and probably do best.
Got a lot more volume out of it. Dial accuracy.
We know you have a lot of questions. What's Telmax? What's fiber optic?
That's pretty good. That's really pretty good there. We're listening to 590 and it's pretty much pointing where you would look for 590 right in this area. Very good. The rest of the alignment, I think I'm going to stay away from. Radio's working. Why would I want to fiddle with it any more than I have? I already got a pretty good boost out of the IF tuning. And that's good. I think we're done. I think we're done on this.
Coming soon, North America's largest indoor boat show, the Toronto International Boat Show. Over 100 exhibitors and
Sorry about that, but I got to test a little bit of volume.
major boating event of the year, January 19th to 28th at the Intercare Center.
We are the...
So there's a scratchy sound there. I don't know if you can hear it. Let me cut the power off here. We're off. Hear that? So the speaker would appear to be in a little bit of trouble. When you turn it up or you play music with a lot of bass where the cone is traveling quite a distance, you're going to hear this sound. And I don't think there's too much I can do about that. I really don't. So it's either because there's a coil in the back of the cone here, which is sunk down inside a slot in a magnet. This is the magnet here. This is the slot. And around the cone is a coil. And the coil goes in the slot. So it's in the slot. If it rubs on the side of the slot, you hear the sound you're hearing. That scraping sound. That's exactly what it is. Scraping on the inside of the slot of the magnet. North pole, south pole. The magnet is like a horseshoe magnet, only it's in 3 dimensions instead of 2. Well, there's an explanation. I don't think there's much I can do about this speaker. So I think you put this in the car, play it at low volume, won't notice anything. Voices, you may not notice anything, but with bass coming out of it from music, you're probably going to hear that scraping sound. Maybe not. Maybe not. Okay, I don't know what else to do to it. I think I'm done. I think any more I do, I'm just taking unnecessary risks on it. Oh, some lubrication. Yeah, we can do some lubrication here. Let's do that. Because this is tricky to tune. So we're working a fair bit of mechanics here. Come on, I gotta turn off this power supply here. There we go. Spin this around. So the tuning has a shaft that comes back about this far in here. Oh, quite the gear works in there. Let's take a look. There you can see the gearing arrangement. So this has an anti-backlash gear system in it, or anti-play, I think is really a better way of putting it. I'm trying to turn it. It's very hard to turn. Of course, I'm working with this little tiny shaft here. That's, I don't get much leverage on that. There's the shaft that's conveying the turning. You can see lots of spots there that could be requiring, and this whole shaft through here could be binding up. What's turning here? Yeah. Well, I can grab this whole thing. I'm going to shoot a little bit of WD-40 right in there. Come on, it's just farts. There we are. Take some time, and then back here, I was looking right in there. Okay. Lay the radio down here. Okay, speaker and all. Get this out of here, get this out of here. Okay, so get gravity helping me on this. And come in through a hole in the back of the radio here. Hit that bushing. Ooh, yeah, that's lots and lots. That's in way too much. Well, not the end of the world, but that's looser. You see, there's an awful lot of mechanical motion inside this radio. A lot of things on the move. Looking for more bushings. So this arm you see here, that's the pointer traveling across, and there's some sliding parts here, sliding in a groove, and those appear to have been lubricated with grease. There, do you see this thing just pop now? It's interfering with something somewhere. Right there. Right there. I think. Not sure what that is. There's a spring system here so there's a bit of looseness in this. Intentional. So we're going to put a little bit of grease on those sliders. Okay, we're going to use a synthetic grease. Let's turn this down all the way. There we go. A little dab will do ya. Okay, get the other side. Now what else needs some grease? I have some. I don't see any other spots here. Okay, let's degrease my finger. It's much easier to turn than it was. Squeak and go away. Not really. Okay, there's another bearing. I don't think that. I can get that. Not sure where the squeak is coming from. Okay, that might go away after a few a few back and forth. Just one. Hey, I'm a winner. Okay, where'd the knobs go? There. Oh, here they are. I'm looking from a different angle here. See what else I can see that's on the move. Nothing from down here. The tuning capacitor should be in here. They've got it all boxed up. You really can't get at it. I would want to do a little bit of lubrication on that tuning capacitor. You know what? This might be reluctance tuned anyway. There may not be a tuning capacitor. Reluctance tuned means actually it is. It's reluctance tuned. There's coils right above here. And when you tune, you're sliding a rod in and out of the coil as opposed to meshing the capacitor. So that's quite common in cars. I'm not sure why. Could be the ordinary capacitor plates. As you're driving down the road, they'll vibrate and shake, and that'll cause the radio to tune here and there just slightly. And what you'll hear coming out of the speaker is noise. You actually convert your car road noise right into the speaker. Maybe. I'm just guessing. That's why they don't like to use big tuning capacitor. Okay, well, I think that's it. I think that's it for this guy. I don't know what else I can do to make him better. So thanks a lot for watching, and I've got the next project waiting to come in here. It's a beautiful, beautiful radio. Far away from this car radio, that's for sure. So thanks a lot for watching, and we'll see what's next.